Project submitted by Ramsha. Project submitted to Dr. Ahsanullah Abro. Project topic is graphs in data structure. So the agenda is introduction to graphs, graph terminology, types of graphs, graph representation, graph traversal, application of graphs. Let's start with introduction to graphs. The graph is a nonlinear data structure that consists of finite sets of vertices and edges. Next, graphs terminologies. Adjacency. Degree. Number of vertices adjacent to the vertex. The path is a sequence of distinct vertices such that two consecutive vertices are adjacent. A cycle that has only one repeated vertices are the first and last vertices. A walk is the sequence of vertices and edges of the graph. Next is types of graphs. Number 1, finite graph. A graph is said to be finite where the number of vertices and edges are finite. An infinite graph, the number of vertices and number of edges is infinite. Trivial graph is a graph which has one vertex without any edges. A simple graph is a graph which does not contain more than one edge. A graph is a multigraph if there are multiple edges between a pair of vertices in the graph. A null graph is a graph in which there are no edges between its vertices. A complete graph is a graph with n vertices and an edge between every two vertices. A graph is a pseudo-graph if it contains a self-loop and other edges. A directed graph, also called a digraph, is a graph in which the edges have a direction. A regular graph is a graph where each vertex has the same number of neighbors. A weighted graph is a graph with edges labeled by numbers, called weights. A connected graph is a graph that is connected in the sense of a topological space. A graph is said to be disconnected if it is not connected, i.e., if there exist two nodes has endpoints. A graph is said to be cyclic if it contains at least one cycle in a graph. A graph is said to be acyclic if it contains no cycle in a graph. Next is graph representation. There are generally two ways to represent the graph data structure. Adjacency matrix is a sequential representation which is used to represent adjacent nodes. If there is an edge between two vertices, the value of corresponding element of the graph is 1, otherwise 0. Adjacency list is a linked representation. In this representation, we maintain the list of its neighbors for each vertex in the graph. Finally, we have application of graphs, which are website, Google Maps and Facebook, etc. That's all from my side, thank you.